Welcome to Mars. This is a world of silent desolation, vast, untouched, and eerily still. Rust-red sand stretch as far as the eye can see. Towering cliffs rise like the remains of a forgotten world. The air is thin, and the silence is suffocating, broken only by the occasional gust of wind stirring up plumes of red dust. And then, there's movement. Not of life, but of something else. A lone machine with its wheels pressing into the ancient soil. The Perseverance rover crawls forward, its mechanical eye scanning the alien wasteland, searching for answers hidden beneath centuries of dust. This is the story of Perseverance's first day on Mars. As we gaze upon the vast expanse of the Martian landscape, a new visitor descends from the heavens, heading toward Jezero Crater, a place that once held water and might still hold clues to Mars's ancient past. NASA's Perseverance rover, affectionately known as Percy, is about to make history. But before its wheels can touch the red soil, it must survive the 7 minutes of terror. February 18, 2021. After a 6.5-month journey covering approximately 293 million miles, Perseverance arrives at Mars. The spacecraft hits the upper atmosphere at about 12,100 miles per hour. Friction rapidly heats the heat shield to temperatures nearing 2,370 degrees Fahrenheit. To ensure a precise landing, Perseverance employs cutting-edge technologies like range trigger and terrain relative navigation. Range trigger determines the optimal time to deploy the parachute based on the spacecraft's position relative to the landing target, while terrain relative navigation uses onboard cameras to compare the landscape with preloaded maps, allowing the rover to avoid hazardous terrain. At an altitude of about 7 miles, traveling at approximately 940 miles per hour, Perseverance deploys its about 70-foot-wide supersonic parachute, the largest ever sent to another planet. This critical step reduces the spacecraft's speed significantly, but it's still not enough for a safe landing. Once the rover descends to about 1.3 miles above the surface, the descent stage's 8 retro rockets ignite, further slowing the descent. At approximately 66 feet above the ground, the sky crane maneuver begins. Nylon cords lower Perseverance gently onto the Martian surface. Upon touchdown, the cords are severed and the descent stage flies away to crash at a safe distance. For the first time in history, cameras aboard Perseverance capture this entire sequence, providing a breathtaking view of the landing process. Moments after landing, Perseverance sends back its first image, a grainy black and white photo showing the rover's shadow cast upon the Martian surface. This initial snapshot signifies the beginning of a new era in Mars exploration. Shortly thereafter, Perseverance transmits high-resolution color images, revealing the Jezero Crater's landscape in stunning detail. Jezero Crater, measuring 28 miles wide, was carefully chosen as the landing site due to its potential for past microbial life. Scientists believe this area was once flooded with water and was home to an ancient river delta, making it an ideal location to search for signs of past life. The dust has settled, the engines have shut down, and the Perseverance rover stands victorious on the Martian surface. But its mission is far from over. This is just the beginning of a historic exploration. With the successful landing and the first images received, Perseverance is poised to embark on its mission. But before it can begin, the rover must undergo a series of checks and calibrations to ensure all systems are functioning correctly. After an intense descent and a perfect landing, Perseverance enters its post-landing check phase. This is a crucial period where every instrument is tested, every system verified, and every function calibrated to ensure the rover is ready for its groundbreaking mission. NASA engineers on Earth carefully monitor each system. The cameras power up, sending back crisp images of the surrounding terrain. The robotic arm moves for the first time, flexing its joints after months of dormancy. The wheels, designed to handle Mars' rocky terrain, perform slow, controlled rotations. Mounted on the rover's mast, the SuperCam uses a high-powered laser to zap rocks from up to 23 feet away, analyzing their chemical composition. One of Perseverance's most ambitious experiments is MOXIE, Mars Oxygen In Situ Resource Utilization Experiment. This small yet powerful device is designed to convert Mars's carbon dioxide-heavy atmosphere into oxygen. If successful, future astronauts could produce their own breathable air and rocket fuel right on Mars. PIXL, Planetary Instrument for X-ray Lithochemistry, is a precision chemical analysis tool mounted on the robotic arm. It scans rock surfaces in extreme detail, searching for tiny patterns that could be microfossils, potential evidence of ancient life. Using ground-penetrating radar, RIMFAX, radar imager for Mars subsurface experiment looks beneath the Martian surface, searching for underground water ice deposits. If Mars ever supported life, its remains may be buried just beneath the soil. Sitting underneath Perseverance is Ingenuity, a tiny helicopter that will attempt the first powered flight on another planet. The thin Martian atmosphere makes flying extremely difficult, but if Ingenuity succeeds, future missions could use drones for exploration. With systems checked and instruments online, Perseverance is ready to embark on its main mission, the search for ancient life. If life ever existed on Mars, the evidence might still be preserved in the rocks of Jezero Crater. Perseverance will drill into the Martian surface, collecting and storing rock samples in sealed tubes. These samples will be left on the surface, waiting for a future mission to bring them back to Earth for detailed analysis. This marks the first step in what could be the greatest discovery in human history. In this enhanced color image taken by the Mars Reconnaissance Orbiter, Perseverance is visible at its landing site just 6 days after touching down. The two bright areas on either side of the rover were cleared by the powerful descent stage rockets. You can also see dark material pushed outward, spreading both in front of and behind the rover. Mars is a harsh and unforgiving world. Temperatures can drop to -80°F at night, and dust storms can last for weeks, reducing sunlight and limiting power. Perseverance must rely on its nuclear-powered generator to survive these extreme conditions. One of the biggest threats here is dust accumulation. Unlike previous rovers that used solar panels, Perseverance is powered by a radioisotope thermoelectric generator, giving it a steady energy supply. This allows it to operate longer and explore farther than ever before. As Perseverance continues its journey across the Martian surface, each day brings new discoveries, new challenges, and new questions about the red planet's past. From its first breath-taking images to testing the limits of exploration, this mission is just beginning.